All right. Hello, everyone. Welcome back. This is our last class together. It is crazy how fast this summer 2021 has gone by, but here we are. So remember that we are not going to have class on Thursday, the 29th, because that will be the day of our final. Please remember that we have the 8.1 and 8.3 homeworks due today. Please remember that if you missed an Excel or have an Excel grade, sorry, I'm a little stuffy this morning, so sorry if I sound off. But remember that if you missed an Excel homework or if you had an Excel homework grade that you just didn't like too much, that I'm giving you an optional makeup for this. So you can do this 9.4 mutual fund one. Then video quiz 4 and 5 are due today and the 29th. So make sure that you get those done. I have graded all of the projects that were turned in on time. I have graded all the quizzes up to and including video quiz 3 at this point. So go back and look for your grades on those. And then video quiz 4 and 5 will obviously be graded this week after their completion dates. Our final, like we just said a few minutes ago, we're not going to hold class on the 29th. I'm giving you the entire day to take that final whenever you're ready. It is still a 2-hour, 20-question test, just like the midterm. You are still allowed a calculator. You are allowed 2 formula sheets, one of them being the conversion formula, excuse me, the 2 conversion formulas from the midterm, and then the other being the formula sheet with all the finance stuff, the mortgage payment, the annuities, all of those crazy formulas. And then remember that you have to show your work, put your name on your work, number your work, and then turn that in to Canvas within 15 minutes. I want to make sure that everyone turns this in. I did not have 100% submission for the midterm work, so I would like to remind you that I do have the, sorry about that. I do have the, sorry, I'm looking at something. I got distracted. Give me a second. My chest is just really heavy today, so I'm having a harder time concentrating. Okay, let me start that over. Remember that you are 100% responsible for submitting your work in Canvas, and that a lack of work submission does give me the right to refuse your grade. Please don't make me do that. I'm much more likely to do it with the final than the midterm. So the midterm, a little more lenient. Final, you have to submit your work. Make sure that you submit your work in Canvas. And by the way, this Excel file, the mutual fund, there is no actual due date attached to this one, so it might confuse you. I know I say 7/29, but that's just because that's the last day of class. I guess I can go back and put that due date in there so that it's not confusing. So I know maybe 1 or 2 people can't find that due date, find the assignment because of that, but it should just be under assignments. So this is our last class, no class the day of the final. Remember that you have the review for the first 4 chapters in Canvas, and then in my math lab, you'll find an interactive review for chapters 5 through 8. I'm going to show you where that is, as well as the formula sheets in just a second. And then remember that the final exam, just like the midterm, is only going to pop up on the day of the final. So you will not see the final exam anywhere in my math lab until the day of the final, and then you can find it in there. So in terms of Canvas, what you have available, besides all the usual stuff, our reviews. So this is not the student view, so you might see 1 or 2 things that you can just ignore, but you have your midterm formula sheet, that'll be your finance stuff. And then you have the midterm review for the chapters 1 through 4, as well as the actual formula sheet right here. Sorry, that's going to be the finance one, which is now available. I thought I had that clicked. That's my bad. So midterm formula sheet, that was the 2 conversions. Math 154 formula sheet, this will be all of the finance stuff. You will be able to find that available now. I swear I had that available before, but I guess I forgot to check it. And then we're going to go to my math lab. Just going to click this one. And then under assignments, so when the final is ready, you will see it right up here with the midterm, but you should see the chapter 5 through 8 review available, which for the second portion of today's class, after we finish talking about chapter 9, we're actually going to do several questions from this because we have just enough time to be able to cover some of that. So I thought that that would be helpful for everybody. So again, when the final is available, which is the 29th, you will see at the top of your assignments. And again, it'll be a 120-minute, one attempt, calculator allowed, formula sheets allowed, but don't add anything to the formula sheets. And again, what that new formula sheet should look like is this. And you've seen me pull it up in class once or twice before. Come on, Canvas. All right, well, I'll click here instead to download it since it's being silly. And this is what I was referring to, which again, we've pulled up previously. So we have the simpler ones at the top, we have the crazier ones at the bottom. We've talked about, and we'll continue to talk about what each of these are used for. So we'll finish talking about the last one or two today. And yeah, so let's not hold things off anymore. Let's go ahead and pick up where we left off, talking about these, quote, annuities and mutual funds and things like that. I was about to show you the Fidelity website and show you a couple of those. I rewound about 2 minutes so that we can have some nice lead up discussion to it. So we'll talk about how we have the different types of categories, and then we'll show you just on one particular website, Fidelity, some of these different funds. And again, this doesn't talk about anything that you could have with Vanguard or all sorts of other companies that I'm not going to just list out. So here we go.
And there's dozens of other companies besides the ones I'm listing. So see which interface you like. You can do this online. Most of them, if not all of them, have apps. If you don't have any clue once you start your account how to actually transfer money from your savings or checking to your Fidelity account and then actually buy the stocks, guess what? There's a Google or a YouTube for it. This stuff can be much easier than most people think. Most people get very intimidated by this, between the potential for loss of money all of a sudden, which again, if you're young, shouldn't matter because you're not going to pull money from this in general for another 30 or 40 years, as well as the, oh my Lord, what do I buy? Well, I've already said one of the things you can do is just invest. You could choose to invest in simple index funds like the S&P 500. And all of these companies have something that mirrors the S&P 500. Or you can buy something that mirrors the NASDAQ if you really like tech, or you can buy something that mirrors the Dow Jones, which is much more the industrial side of things. Or maybe you want to buy things that are all based on medical technology, or maybe things that are just retail. There are bundles of these out there, and you can follow this link to see a bunch. How much time do I have? Here we go. So I like Fidelity. I won't lie, I use Fidelity, so that's what I have a little more reference with. So this page right here just takes you to a whole boatload of things you can invest in. This is not even all of them. This is just some samples, and this is domestic equity, which is things like your blue chip fund. And if you click one of these, it'll actually show you how it's done over a 10-year span. So anything you put in 10 years 10 years ago has grown by this much per year. That's a large number. This is kind of a crazy year because of what happened in March and how tech kind of just shot past it. So don't expect this usually, but holy cow, that's a big number. You can see expense ratios. So that's a portion that they'll take out every year. Now, admittedly, almost 1% is a little more larger than average, but I mean, you're paying 0.75% to get 20% growth a year. I'm okay with that as long as that continues. I'm not promising it continues. They will show you where if you hit composition, their top few holdings. So they've got Apple, Amazon, Microsoft, Google, Facebook, Nvidia, Tesla, Salesforce, Marvell, which is a technology group, and then Visa. This is not all of their holdings. It just makes up half. So there's 418 companies. So this is just the top 10. So they're saying about half of your investments are in these companies. And oh boy, these companies grew a lot over the past year. If you don't know about Tesla, you need to find out. And again, past performance does not dictate future performance. I'm not telling you to invest in Tesla, but I'm saying if you had invested in Tesla a year ago, you made some money. Same with all these companies up here. All right, so pretty aggressive tech funds. Maybe you don't like tech. Maybe you just want to do that S&P 500 thing I kept talking about. Where is it? I am not seeing it. I know the code. It's FXAIX. There's just too many letters up here on this page. That's why. Index. That's why. Domestic stock. Where are we? Am I blind? All right, so I'm just going to hit search FXAIX because I know what that one is. I'm just trying to rush and it's not working for me. So here's that thing that mirrors what I call the S&P 500, which again traditionally returns 7% over a long span of time. Right now we've had really insane growth over the past 10 years, so it's about twice what it normally is. So a lot of people say, hey, expect this not to happen much longer. And again, past does not dictate future. Who knows? Maybe things are going to change, maybe not. I don't know. You could just buy a little bit of every single piece of stock out there that's not a penny stock. So back on this page, under index, I swear that should have been on this one, FSKAX. Oh, there it is. I am blind. There it was. This is the total stock market. So this is buying a little piece of every stock on average worth more than $1. And look, even that's grown pretty well. I mean, I'm just trying to show you that these numbers aren't made up. I didn't pull these out of thin air. We've had pretty good growth over the past 10 years. When you buy a little bit of everything. Now, if you buy 10 stocks, I can't promise you those are all going to go up. Maybe they will all go down. If you bought something like Nikola, yeah, you had a bad time. Why is that happening? I didn't click anything. So that's why we suggest that people buy mutual funds, or at least consider the option of buying mutual funds. I'm not telling you what to do. Because when you buy bundles of stocks, some will go up, some will go down, but on average, you have more going up than down, and the stronger companies go up significantly to make up for the weaker companies going down, and you still make money. Now, maybe you just invest in Apple and Tesla and you make $10 billion in 3 years because those are some of the best growing stocks. But again, who knows what happens 2 years from now, 5 years from now, 10 years from now. Maybe you do a bit of both as you learn. Maybe that's a good idea. So again, you've got different sectors where you can just buy just healthcare stuff, and there's a few options there. You can buy just real estate stuff. You can buy energy stuff. So let's look at energy. I feel like most of the energy ones are red, and it's not awful, but I don't know. I don't want to lose 3% a year over 10 years. Maybe these will pick back up. A lot of people think energy is struggling right now because we're getting ready to shift the winds from oil to much better resources, electric cars and things like that. So maybe that's why oil is struggling. And again, I'm not telling you things, I'm suggesting reasons for things that are happening. Financial portfolios, information tech. I mean, tech has done pretty well over the past 10 years. That's not bad at all, 21%. Here's another tech one, 20%, but the 1 year growth has been better in this one than the other one. 37 versus, sorry, I'm looking at the year to date. 40% versus, come on, computer, you're killing me. Well, it's on there. This chart shows the theoretical growth. If you put $10,000 in 10 years ago, what it would turn into, and that was like $70,000. This one's about $60,000. Yeah, so this just one tech portfolio versus another. One of them had a 1 year growth of almost 60%. The other, it was 40%. Are you supposed to get upset if you invest in the one that's 40% and that your buddy invests in the 60%? No, you should be happy that you got 40% growth. That's the mindset to take positivity. Oh man, I didn't buy Bitcoin when it was $100. Crud. No, that tells you, hey, take this money and invest in something later. It doesn't have to be Bitcoin. It doesn't have to be something super, super aggressive. Just invest in something. But broaden your horizons, invest in lots of different little things. That's what most people would say the concept is to do. Thematic investing, these are all new. I will be honest, I've never seen these before. They are so new. So because they're new, you're not going to see 10-year, 5-year numbers. It's just going to see, what it's done recently, which they're saying this has been around for like a month. Huh, interesting. I got more research to do. So those were all Fidelity funds. If you have a Fidelity account and buy Fidelity funds, they don't charge you fees. If you get a Vanguard account and buy Fidelity funds, they're probably going to charge you a fee in most instances. Vanguard would have their own sets of funds. They won't be exactly like those Fidelity ones. They'll have the index funds that mirror the S&P and the NASDAQ and the Dow and the total market, but they won't necessarily have that same technology fund. They won't necessarily have that same energy fund that I showed you. So most people are gaining money on that interest. And that's what we saw with that growth, the $10,000 turning into $70,000, because every year on average, it was growing 21%. Not saying every year it grew 21%. First year it might have grew 10. The second year might have grown 30. The next year it might lose 30%. Then the next year it might gain 80%. It's just saying it averages out to that 20% number. But that's not the only way that we gain money in stocks. We can also gain money by something known as dividends, which we did some math with dividends one time, a long time ago. But this is just money that you get for free because the company is profitable. So many companies will say, hey, we made some profit. We're going to pay back some of this profit to our investors. So you have your interest from other people buying the stock, from it being well sought out after. And then you have dividends where some companies go, hey, we made $1 million this year. Let's give $1 to each person holding a share. And they give you money based on shares. Some companies might give you 3 cents per share. Some people might give you $5 per share. It depends on how profitable and how generous they are. Not all companies offer dividends on their stocks or mutual funds. Amazon does not offer dividends. Amazon doesn't do a lot of things that Amazon should be doing, in my opinion, like paying their employees better or giving them better working conditions or yada, yada, yada. But let's not get into that. And there are plenty of companies just like Amazon in that regard. I'm just naming one because it's one of the biggest companies out now. So some people will say, I really like dividend investing because then I can just take those dividends and pocket it and live off of that maybe. Or you could take your dividends and reinvest. One thing I've noticed is that a lot of companies in the energy sector will pay really solid dividends, but the counterbalance is that they're in the red each year with their interest. You're losing a little bit each year. So you might get 7% dividends, but then you're losing 3% per year. So basically that means you've gained 4%. It's not awful, but maybe you could have gained better money somewhere else. And again, I'm not telling you to not dividend invest. I'm telling you to research it, consider it, and make your own decisions. So one of the most important things for you to do is to figure out this retirement game. Do some research. Hopefully I've helped a little bit here, but I can only say so much without actually starting to give advice, and I'm not allowed to give advice. I'm allowed to just give perspectives. So we started out with that simple idea of, all right, take your Starbucks cup of coffee, $3.50 a day for 50 years, and you become a millionaire by investing in things like this. Maybe quicker if the market's better, maybe quicker if you make better selections. I don't know. But then I also said, well, another thing that you can do is you can bump up your investment over time. When you're 18, $3.50 a day is a lot of money. When you're 40, if you've been financially savvy over time, $3.50 a day shouldn't be a lot of money anymore. Maybe you can start putting in $5 a day or $7 a day and hit that million sooner, or turn your goal into $2 million maybe, or something like that. But one thing that is ultimately important, and this is one of the number one issues of the American, besides not having their 3 to 6 month emergency fund sitting in savings for, like I said, emergencies. What is it? 90 or 95% of Americans can't afford $1,000 emergency that happens just right now. The other issue is credit cards. People have credit card debt, on average $8,000 to $10,000 worth of debt per person. Oh my Lord, please pay off your credit cards now. I'm crying for you if you don't pay off your credit cards. And the third is mo money, mo problems. More officially known, not by the wise man once said, but as lifestyle creep. All right, so you're 18, you're living off a $10 an hour job or less, and you're living with your parents, and you just can't buy a lot of things. And then you get out of college and you get your $40,000 a year job, and you get your apartment and your slightly used car and your whatever else, and you start paying off your student loans, and you go, well, I'm making $40,000 a year now. Instead of going out on Saturday and spending $10, I'm going to go on Saturday and spend $100. Or instead of buying that $10 pair of jeans at Old Navy, I'm going to buy the $100 pair of jeans that, I don't know, name a store where you get a $100 pair of jeans. Clearly, you know where I'm shopping. And $10 is exaggerated, maybe 20, 25. That's more average, but you get the point. What is it, H&M? You can go and get $6 shirts instead of going somewhere else and getting $50 shirts. So again, most people, they start making more money, and that means they start spending more money. But unfortunately, we don't build our monthly budgets or our yearly budget or whatever it is you want to do. So we go, oh, well, I'm making $40,000 a year. That's an insane amount of money in comparison to what I used to make. So I'm gonna start spending more. And then the credit card bill rolls in, and you go, oh, whoops, I shouldn't be spending that much money, I guess. But then you keep spending it because you've already adjusted to it. You've gone from hamburger to steak, and you can't go back to hamburger. That's actually a poor comparison, because, who can't go back to a hamburger? Let's say you've gone from bologna to steak. You're not going back to bologna after that, at least not Oscar Mayer. Raises his hand, grew up on bologna. Not ever going to buy Oscar Mayer bologna again in my life. So lifestyle creep. Avoid it as best as you can. Just because you make that $40,000 a year job, just creep up a little. Don't start spending $100 out on your Saturday. Maybe spend 15 or 20 bucks out on your Saturday. Learn to meal prep at home. Things like that will help you avoid that lifestyle creep. And then you've got more money to invest. And then that money can make you money. It can work for you. It can make you $1 million. Maybe instead of retiring at 67, you retire at 57. The money you make now has more potential than the money you're going to make 30 years from now. Because the money you make now, you can throw in these investments and make it work for you. And that $10 you put in now can turn into $100 later. Let's go to our annuity calculator. Spell annuity correctly first. Da-da-da-da. Let's say we invested $1, just $1 at our average 7% return accounted for inflation, which would be 9% if we assume 2% inflation. And this is a dollar that we put in when we're 18 and we plan on retiring at 67, so 49 years. Look at what this $1 will turn into. $68. And that's with again, this historical average that maybe you can beat, maybe not. I'm not telling you what you can or cannot do. I'm not telling you how to do it. I'm giving you options to look at past performances and make decisions based off of that. But the $1 you put in today is worth $68 in the future. Now you might say, well, that's in future dollars. Well, let's turn this 9% into 7, so that would account for inflation, and now we're thinking in terms of our dollars now. So that $1 you invest today is now almost $30 later. So what would you rather have, your dollar today or $27 in the future? And you're not just going to invest $1 today, you're going to keep adding to the pile. So you've got $1 that you start with, or you start with $20 now, and then every month you're going to add $100 in, whatever, something like that. Oh, there's $472,000. Oh, well, Mr. Beckner, eventually I can add more. Well, you'd have to do this for 20 years and then for 29 years. And you can adjust for this, or you can do it in Excel. You go, well, Mr. Beckner, I'm capable of putting $200 a month in right now. So adjusted for inflation and all that, now you've got almost your $1 million later. Oh, Mr. Beckner, I can't handle that. All I can do is $50 for now. All right, so this account where you're doing 50 is going to earn you $236,000 by the time you're ready to retire. And then hopefully you've got another account that you've been adding to that, or you've been adding to this pile and this just isn't accounting for it. Put very little increments of money over a long period of time invested in the right place. I'm telling you, will make you money. All right. Pay off your credit cards, invest wisely. Oh, here was just a quick YouTube search I did. How to invest in Fidelity, and the second one, how to buy stock in Fidelity, takes you step by step through it. Doesn't have to be stock. It's also mutual funds, bonds, ETFs, whatever. Which, by the way, I don't think I said this, but I want to see where it is in writing. Here it is. Your IRAs, your Roth IRAs, your brokerage accounts, all of them can access the exact same mutual fund. So if I have a Fidelity account and I wanted to buy that FXAIX, which was that S&P 500 mirror, a little piece of the top 500 companies in our country right now. If I wanted to buy that, I can buy it as an IRA, or I can buy it as a Roth IRA, or I can buy it as a brokerage. There are just little drop-down menus in Fidelity to do that, or in Vanguard, or in whatever place you choose to hold your accounts. You can hold accounts in separate places. Now, if you have a Fidelity and a Vanguard account, you go, well, all right, if I can put $6,000 into an IRA, that means I can now put $12,000 because I have two accounts. Wrong. It's $6,000 across all of them. So if you put $6,000 in a Vanguard IRA and then $6,000 in a Fidelity IRA, the tax man's going to come after you at the end of the year. So don't do that. $6,000 total. All right, let us remind ourselves about these formulas. Whenever it wants to pull up, there we go. Good Lord, this computer is just moving at a snail's pace today. The four that we've used the most were these three and then this one. These three are for one-time investments. P means a one-time borrow or lending situation, whether you're borrowing the money or you're the one putting into the savings account, whatever. It's a one-time investment. So you use these three formulas when it's a one-time investment. Well, how do you go from there? How do I know whether you use first, second, or third? Well, use the first one when it's compounding annually, which means the N is 1, so we don't need to see the N. We use this one when we're compounding in times, but also these are for when we know the starting value, because we have the P. This third one is when we know the ending value. And if you say, oh, well, what about if it's compounding annually? Then just remove the N or make the N 1. This fourth formula was from converting APR, which is what we call R, to APY, the rate as it's compounding monthly, what it would be equivalent to if you only compounded once per year. That's what that does. The next three formulas, you see that word annuity, which the word annuity means, that's not far enough down. Let me pull this back. The word annuity means, oh geez, it scrolled out while I was drawing. This means that we're making multiple deposits. Payment, payment, payment. Payment means something you're doing over and over and over. That's the easy way to tell whether you're using an annuity formula or the top three formulas, whether I tell you it's a one-time deposit or it's a multiple time deposit. Whether the example tells you that. How do you know? Read the example carefully. Pay attention. Okay, well, how do I know which of these three formulas to use? Well, between the first and the second, it's, now my internet's unstable. Good grief. It must be the last day of class. These two are for when you know the monthly payment or the annual payment or the quarterly payment or the daily payment, and that's the deposit. So you know how much you're putting in every month, every day, every year, whatever it might be. This first one, of course, is when you're compounding once per year. This is when you're compounding n times per year. It's just a matter of whether there's an N or not. Sorry about that. This third one is for when you know the ending amount. So I want $1 million when I retire. That's the one I use. I want $500,000 when I retire. That's the one I use. I want $2 million when I retire. That's the one I'd use. If I say I know I can put $100 a month away, I'm going to use one of these two, specifically the second one because I'm doing it monthly. If I say I can put $500 away per year, I'm using this one because I know how much I'm putting away on the intervals, but it's annual, so the top one. The fourth formula down here is loans, completely different. We've already talked about and used that one previously. This is your cars, your mortgage, your student loans, boat loans, your home equity loans, anything like that. So PMT here is the monthly payment you're paying to the bank for them loaning money, whereas in these three, payment is how much you're putting into an investment. So if you put $10,000 away for 50 years, if you put $10,000 away for 50 years, it's one of these two because that's just me putting away $10,000 once. If I'm putting $10,000 a year in for 50 years, then it's one of these two. It just matters, whether we're compounding annually or monthly. If I'm putting $10,000 a year, that means annually. If I'm talking about a car loan, a home loan, a student loan, it's this formula. So you have to know which formulas to use. All right, so let's try out one or two of these in the little bit of time we have left to spare. And I really do focus heavily on that 7-figure retirement plan. So Bob wants to retire with $1 million. If he can invest monthly into an IRA annuity that earns 9% compounded monthly, so again, without inflation, that's the historical average. Depending on where you do your research, some people will say 7, some will say 8, some will say 9. I've seen someone say 10, but 9 is the number I see the most. Bob is 25 and will retire at 65. How much should he invest each month? Now, this is assuming that Bob's going to keep putting the same amount in every year. We've already talked about how, in theory, Bob should be adding to that pile each year because Bob hopefully doesn't have a state job and makes a little more money each year. Shots fired. So if Bob gets a 3% raise, maybe he puts 3% more into his retirement in the next year. If Bob gets a 5% raise, maybe he puts 5% more into his retirement next year. Or maybe Bob pays off his mortgage and now he can put 15% more into his retirement each year. All right, so Bob's 25, he's going to retire at 65. That gives him a solid 40 years, and we're going to say 40 years exactly. We're going to say it's his birthday at 25 and birthday at 65. We have our R, we have our A. A is the ending amount. He's not putting in $1 million. He's not putting in $1 million once or monthly or yearly. This is the ending amount. And then this is our rate, our APR. We're compounding monthly, so that's our in. 25 to 65 means we've got 40 years worth of time to invest in. So we want to say a couple of questions. How much should he invest? How much should he invest each month? How much did he invest total? And how much was free money, aka interest? Let's get to those questions later though. So that means this is an annuity problem. I even give you the word annuity. I don't have to give you this word. If I don't give you this word, this problem reads the same because I said how much do we invest each month? That's a regular payment. That's an annuity. So it would not be one of the top 3 formulas. It's one of the bottom 3 formulas. The question is, how much should he invest each month? We know the ending amount. So if we go to our formula sheet, we know the ending amount, which means we're on this guy right here. Payments needed to achieve a financial goal. So let me just copy this bad boy so I can get it on the same page. If Word will behave. And then we just put all the numbers into the spots they go. Circle goes in the circle, square goes in the square. There is literally nothing challenging about this. Besides circle going in circle, square going in square, it's just practice. Oh, what do I put for A? What's the A? Well, that's the ending amount, $1 million. So our payment is $1 million. Do I have the right number of zeros there? Yes, I do. Then parentheses, R over N, that's the 0.09 over the 12. How'd you know it was 12, Mr. Beckner? Why isn't it 1? Because we're investing monthly. There are 12 months in a year. All over, bracket parentheses, which is just a double parentheses in your calculator. 1 plus R, which is 0.09, over N, which is 12, raised to the NT, which is 12 times 40. And then this minus 1 over here. Don't worry about what the pieces in this puzzle mean. Just plug them in and go. So, calculator. On, clear my screen. $1 million. $1 million. And times. You might have to hit times, not just the parentheses. Depends on your calculator. 0.09 divided by 12. Close the parentheses. Big fraction bar means divided by. Bracket means another parentheses, then another parentheses. So I just typed these two things. Then 1 plus. Now I'm here, the 0.09 over 12. 0.09 divided by 12. Then we're going to close that parentheses. Now, if I go ahead and raise this when I'm about to do it wrong, and I'm going to correct it to 12 times 40. If I do this in my calculator, this is wrong because my calculator doesn't handle this properly. What I'm really supposed to do is pre-multiply that exponent, and 12 times 40 is going to be 480. So make sure you do that first. So I need to do 480. And then let me just delete everything after that to be safe. Then the -1 and close the bracket, which is a parentheses in this calculator. Drum roll, please. Da, 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 da. A measly $213.61. That's per month. I say measly, but yes, I mean, to most of us, that still probably sounds like a lot of money. But again, with good financial decisions, making budgets, paying off your credit cards, not making frivolous expenses just all the time, this is achievable with a career. Also, maybe you're not doing this in IRA, maybe you're doing this in 401k and your employer is doing a dollar match. Maybe that means you only put $106 and some change in, about $107, let's just round up, $107. Then your employer matches that $107 and boom, you hit your 213. Now, I didn't say whether this was IRA or Roth IRA. Maybe this is tax-free interest, maybe not. That's not the point of the problem. All right, so next question. How much did he invest and how much was free money? How much did he invest? Well, we put in $213 a month and 61 cents for 480 months. 40 years, 12 times per year. So the amount he invested, I'm just going to put it here, is just the payment times the number of payments, which is 213.61 times 480. This was a formula we gave you like day one of class. Actual class, not talking about the syllabus. So let's just take that 213.61, and let's multiply by 480. Drum roll. He put in $102,532.80. And then the interest, the free money, would be the difference of what he ends with, the $1 million, and what he invested, which was the $102,000.80. Some people accidentally just do $1 million and subtract 213. No, you invested more than $213.61 because you did it 480 times. So be careful there. So 1 million, 1, 2, 3, 4, 5, 6, minus 102, and you can already see it's a big number, 532.80, and it's $897,467.20. That's the free money. And if you did this in a Roth IRA, because we're investing less than $6,000 a year, guess what? That $900,000 is all tax-free. That is your money. You cannot beat that. You cannot beat that. You cannot beat that. You have to wait. You have to be patient. Oh, but Mr. Beckner, you can't take it with you when you die. Oh, man. Oh, I've heard that too many times. Yeah, but at least when you're 90 years old, you have something to live off of instead of the government's Social Security, which is nothing. And you can pass it on to your children and your children's children, and you can build generational wealth and you can climb the ladder socially and financially and all those good things. You can also be extremely generous with it. If you don't have children, you can just donate your earnings after you're gone or something like that. And I'm really getting into some deep stuff now, I know, but I've heard all the retorts for investing and why you shouldn't do it. And the biggest one is always, you can't take it with you. And you know what the last half of that statement is. Let's do this last one and we'll call it. We have just enough time. Bob can invest $500 monthly into an IRA, a Roth IRA that compounds monthly. So I'm being specific here. $500 a month would be exactly $6,000 a year, which means the interest would go tax-free. Now how much did he get for free? It actually has nothing to do with the tax part. I'm just saying Roth to get you used to the language. And yes, the interest here would be tax-free. Last time, if it was a traditional IRA, that means we would have not paid taxes on 100 grand and we'd pay taxes on the 900 grand. Not optimal, but still not the end of the world. You still got a whole boatload of money. And maybe there are ways you can talk to a financial advisor, not your math teacher. Maybe there are ways that you can lessen your taxes on that if you are paying taxes on that 900 grand over time. All right, so $500 a month. This is not how much he wants at the end. This is an initial amount, but it's not just a one-time deposit. It's an over and over deposit, which means that it's an annuity. So we're using the formula with a payment in it. And we're compounding monthly, we're investing monthly, so that means we cannot use this one. This is compounding annually. We're on this compounding in times per year. So this, highlight the whole thing, Rodney. This is the formula we'll use this time because it's a repeated deposit and we're compounding monthly. Sorry, I know you see the numbers there. Just ignore them for a second. Bob is 35 and will retire at 65, which means he's got 30 years. This $500 would be our payment. It's going to get 6% return, so maybe Bob's a safer investor. Maybe Bob invested in bonds more than someone else while he was younger or something like that. Or maybe the stock market just didn't return as much over his life. Again, past does not dictate future. There's our R. N is 12 because we're compounding and depositing monthly. FYI, for the math, these have to be on the same interval. In reality, they don't, but for these equations, they do. It's oversimplified. So same thing, how much will Bob have to retire and how much is free money? How much is interest? Actually, not the same as last time. This is different. How much will he have to retire? That's the A. So our numbers, the payment's 500, the time is 30, the N is monthly of 12, the R is 6%, so 0.06. So that means when we plug these into the formula, again, I'm going to do this kind of quick. We're going 500 bracket parentheses 1 plus 0.06 over 12. Please slow this down on YouTube if you have to. Then raised to the MT, that's 12 times 30 minus 1. Then all over parentheses R over N, which is 0.06 over 12. You might go to the internet and find a formula that's slightly different. That's because there's assumptions made here. You can see some really crazy formulas on the internet. All right, remember you need to pre-multiply this exponent, so the 12 times the 30, please note that that's 360. So that's what I'll type in my calculator to make sure there's no errors. 500, double parentheses, 1 plus 0.06 divided by 12, close a parentheses, raised to the 360, then minus 1. Be careful if your calculator makes a true exponent where it's smaller and above, you'll have to hit right then the minus 1. Close the bracket, divided by parentheses, 0.06 divided by 12, close that parentheses, drum roll, 500 million and some change. 502, 257, 52. Oh, that's horrible. He doesn't have $1 million. Well, that's less time and a smaller interest rate. He's making more than double the payment in the previous scenario, and he's still only halfway there because less time and lower interest rate. If you are 18 or 20 or 25, start yesterday. If you're 35, start today. If you're 45, do whatever you can. If you're 55, do whatever you can. You still have time to make up for this, but you'll have to make larger deposits or retire later. How much is free money? Oops, spoiler alerts. There's our A. I had that typed up. So the interest, well, first of all, we have to know what the total invested is, which would be the monthly payment times the number of months. There's 360 months in 30 years. 500 times 360 would be 180,000. Oops, that wasn't an answer to anything. It could have been, but and then the interest is the difference of what we invest and what we earn, backwards order. So 502, 257, 52 minus that 180,000. 502, 257.52 minus 180 grand. And that's 300 some change, 322, 257, 52. I mean, that's still a decent amount of free money, and in a Roth IRA, it's tax-free, but it's not as good as the previous scenario. Again, the previous scenario was a longer time. So you have more time at the beginning to make riskier investments, and maybe that's how you got your 9% return. This scenario is less time, so we have to make a bigger deposit, and maybe we only get 6% because we're a little safer. Maybe we're too safe, arguably. Or maybe the market just sucked over that 30-year period. But still, quote, sucking still earns you $300,000. So I wouldn't say it completely sucked. Sucking, in my opinion, would mean you lost money. You now have less than $180,000, which is pretty rare. All right, so on that bombshell, I'm going to put a problem up here on screen. You can pause this. Actually, no, I don't have the details up here. I thought I had it written down. I just have the amount financed. Never mind, ignore it. We did a house problem previously, so that's good enough last class. All right, so I know this was a lot to take in all at once. I really hope that maybe you'll replay some stuff on YouTube, maybe slow it down, maybe do your own research. I hope I've encouraged you over the course of this class to do this stuff, to do your research, to invest. Anything helps. Anything helps. Please don't be the average American. If there's one goal I have in my career, it's to help people, and it's either help people learn algebra and learn calculus to become engineers and scientists, or it's to learn basic principles of finance so that they don't go to retirement age and not have anything besides Social Security or maybe a crappy pension. And I use the word crappy there subjectively. It's still better than nothing. All right. It has been an absolute pleasure. I know this has been a weird way to teach and learn for everybody. I hope that
All right, so just give me a minute or two, and then I'm going to set up for that review portion of things, but we're done with all the use of the formulas for the new material. All right, so like I had said, once we had finished the Chapter 9 material, I just wanted to pull up the review from my math lab and do a few questions, pretty much as we can get done over the next hour, and that's what you'll be seeing in just a second. And remember that the final exam is only going to cover up to and including Chapter 8. I didn't want to put Chapter 9 on it since we're finishing it today. It just doesn't seem very fair putting material on the final from something 2 days prior, especially when the formulas are a little beefier, they're a little busier than what we had been doing in the past. But again, I do advise you to use them. But remember that 2 years from now, 5 years from now, we've shown you those websites in case you forget how to use them. And all of them are fairly accurate except for the annuity one, which we talked about, has its slight inaccuracies because of the way it chooses to calculate the compounding and the intervals and blah, blah, blah. But the mortgage one is dead on. The credit card one is dead on. So those are awesome. The annuity one, I mean, if it's the difference of, in reality, it's $1 million and $500 and it tells you it's $1 million, no one's going to really care about being off by $500 when, oh, hey, I've got $1 million and this tells me I'm going to have about $1 million. That's pretty awesome, I'd hope. So websites are awesome, but again, the formulas are there for the technicals as well as Excel. You can do all this stuff in Excel like we've shown you. All right, I'm going to stop rambling. Let's get to this review.
Then we'll come back to it before 2:30. Right. So remember that the review that is in My Math that looks like this, that's interactive, where you have some of the questions with view an example or help me solve this. Not every single one of them has it. I know at least 2 don't have it. Actually, let me say at least 1. I'm pretty sure 2 don't have it, but I know at least 1 of them definitely doesn't have it. And then for the chapter 1 through 4 stuff, you have the paper pencil version with only questions and answers and no actual help between. You just needed to use your notes, your previous homework problems, because most of those problems could be found in the previous homework, or at least very similar, and those had to help me solve this stuff. So the distance you drive is proportional, which means if one thing doubles, the other doubles, to the amount of gas used. Now remember, the word proportional by itself is what means if one thing doubles, the other thing doubles. We can throw in other words like inversely proportional, which actually means as one thing doubles, the other halves. Or we could throw extra words in there like it's proportional to the square, and then there's no if one thing doubles, the other doubles, or if one thing halves, the other doubles, or anything like that. It's completely different. And they can vary with square roots, squares, all sorts of other things. But all we said is proportional, so as one thing doubles, the other doubles. So the distance you drive is proportional to the amount of gas used. So this is assuming that we're going to be driving a constant speed. There's not going to be stop and go traffic, no lights, no quick acceleration. We always keep simple assumptions for problems like this. So they say that driving 138 miles uses 6 gallons of gas. Complete parts A through C. Well, the 6 gallons of gas, this one is very obvious that would be 138, right? 6 gallons of gas takes you 138 miles. This is 6 gallons, and that would be 138 miles. Hopefully the 0 makes perfect sense as well. If you use 0 gas, you can go 0 miles. You have to use fuel in order to move. This was another important concept of proportions, that 0 in one thing is 0 in the other thing. And we said that we deal with a ton of proportional things in the real world, in our real lives, after we're done with QR class. But there are certain things that aren't proportional, or that you might think they are, but they're not really, like temperature, or things that have a fixed amount and a variable amount. With that fixed amount being non-zero, that's what causes this to not be zero, but that's a whole other problem. All right, so the next one, now you might say, oh, okay, well, I need to figure out how many miles I can get per gallon, so I need to do 138 divided by 6, and this is arbitrary. I don't have to do this, but you could. If I did 138 divided by 6, we can see that we can go 23 miles every time we use 1 gallon, because the 138 is miles, the 6 is gallons, so the units would be miles over gallons. So 23 miles per gallon is our fuel consumption rate. Now again, we don't actually need this based on how this table is set up, because the next is a 12 and then an 18. We're just doubling and tripling these values, which means we could just double and triple that 138. So if you double 138, let me make sure I'm in my calculator, 138 times 2, you get 276. And if you triple 138, or if you just add another 138 to that, whichever way you want to do it, you just every time you add 6 gallons, you add 138 miles. So you could do plus 138, or we could have done 138 times 3. And either way, you still get 414. Now, maybe you didn't do it this way. These are correct. Maybe you said, all right, well, my 23 miles per gallon, then just multiply by the number of gallons. Miles per gallon times gallon, you would see everything cancel. If you have miles per gallon, miles, so MI, and then you multiply by something in gallons, the gallons would cancel, and you'd be left with miles. Now, of course, you would have to throw the numbers in there, 23 times 6, 23 times 12, or 23 times 18. And guess what 23 times 6 is? It's 138. 23 times 12 is 276. And 23 times 18, you guessed it, is 414. So they're all good. Fantastic. Great, grand, fantastic, wonderful. Then they say represent the relationship between the distance driven D and the gas used G with an equation. and they say the distance you drive is equal to some number times the number of gallons. Well, that was the thing we got when we took the 138 divided by the 6, the 23 miles per gallon. Also the thing I used if I just wanted to multiply the 23 by the 6, the 12, or the 18. So there's our equation. The distance you drive is 23 times the number of gallons. And you can't say it the other way. You can't say the gallons is 23 times the distance. When you get your answer, it wouldn't make sense unless you're driving a semi with 2 billion pounds of concrete in it or something, and you're going 1 mile for every 23 gallons of gas you use. Ooh, that sounds awful. Next up, what is the graph of the equation that represents the relationship between the distance driven d and the gas used g? So it's very important to understand independent versus dependent. The independent is the left side in this table, and independent always goes on the bottom. So gas, 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 those all make sense. What they could have done is have two of these answers, or more or less, have distance on the bottom. And while you could certainly make a graph with distance on the bottom and gas on the vertical, it would just be weird to do it that way. All right, so this one looks ridiculously steep. This one looks a little flatter, flatter, and then flatter. And C and D are actually not too far off. It's just this right side has a height that's almost 250. This height is about 150. So let's see. Our gallons are going between 0 and 20, and here they're going between 0 and 18, so that's a good range. And their distance is between 0 and about 400 and some change, so 0 to 500, about the same. So we know they go through the origin. All four of these graphs use the origin, so that's not going to help us. I'm going to suggest that the only other point we absolutely need to look at is the last one. That point right there will tell us all, but the others in between could be used as well. 18, 414, that means we're going to go right 18, and we're going to go up 414. So if on this one right here, if we go right 18, that's about here. And then if we go up, let's just say about 400, every one of these marks is 50. So that would be about here, and that's not where the line is going through, so it's not A. This one over here, if we go right 18, and then we're going to go up, so 18 is about here, because every mark is 2. That point should have been here, actually, not that one. Just ignore the left one. So right 18, and then up about 400, roughly. So every 2 marks is 50. So here's 500, 450, 400. That actually looks pretty good. I think it's going to be B, but let's before we answer firmly, let's check the others. Go right 18 and up about 400. So that looks wrong. Go right 18 and up about 400. And that looks wrong. So yes, it is B. It's kind of a process of elimination, but we also used logic and reasoning to get there. Now, does this have to be a multiple choice answer? No, I could give you a paper pencil test in theory and then just ask you to draw the graph. But the thing is, the media tends to give you graphs. So that's why it's honestly not the worst thing in the world to give a multiple choice scenario here. All right, let me clear my screen so I can actually answer. And we said it was B. And it looks like we got it right. And there we go. Question 2, short and simple. Plot the ordered pair 8, 7. That's just right 8, up 7. You can click or you can drag around. But if I'm going to go right 8 and then I got to go up 7, that's where the point would be. And that's it. Just don't go right 7 and up 8. You got to get the left, right, and up and down correct. The cost of an airline ticket is proportional to the distance traveled. So no inversely, no square, no other nonsense. So this is just a y equals kx setup, or as one doubles, the other doubles. And it's at a rate of $36 per 100 miles flown. Assume there is a base charge of $75 though. So actually, this is not a 100% proportion problem because there is a fixed cost or initial cost here. So we have a variable cost and a fixed cost. The 36 is the variable amount, which if all we had was the variable amount, then it would be a direct proportion. We could say 100 miles would cost $36, 200 miles would cost $72, 300 miles would cost $108, et cetera, et cetera, et cetera. But with that fixed cost, we can't forget to add 75 each time. So if we go 0 miles, for some reason we bought a plane ticket from Norfolk to Norfolk, they would still in theory charge us $75 just to stare at a screen. I know that sounds silly, but we're going to go with it. So that would be $75. Then if we're going to go 100 miles, we're going to pay the $70 flat fee plus the 36 for the 100 miles. So we're going to go the flat fee plus the 36 for the 100 miles, which would be 111. To go 200 miles, we'll pay $36 twice because 200 is 2 times 100. So that means we'll pay $72 for the distance plus the base charge is $75, being 147. And then if we go 300 miles, we'll pay this $36 3 times, because 300 is 3 times 100. So we'll do 3 times 36. That's our variable cost. So $108 for the mileage, plus the fixed cost for running the airport and everything of $75. So 183. And everything looks good. Then they say to represent the relationship between cost and distance, and you'll notice that they don't just do y equals kx in a setup or c equals kd setup. There's a plus a number because we have a variable amount and a fixed amount. So the thing that goes with the variable is the variable amount, the thing that's a per something. So that's the 36 going with the d, which is what we multiply by 1, 2, or 3 in these instances. And then the fixed cost is what we add that doesn't have a variable, so that's the 75. What happened? Oh, I know why. Because this distance is in miles, and this is per 100 miles. So let's just pretend like I did that on purpose. 36 times D, that means if you went 1 mile, you'd pay $36. That's not quite right. We're going $36 for every 100 miles. So we need to do 36 divided by 100, which is obviously 0.36. So that is what this number should be. It's not 36. If it was $36 per mile, this would be 36. But because it's per 100 miles, that means we're really only paying 36 cents per mile. And that should be correct. There we go. See, I didn't pay attention, and I got something wrong initially. And finally, what is the graph of the equation? 2 of these you can throw out immediately, and that is B and D. You know how I can throw out B and D immediately? Because the number in front of your variable is positive, which means that your line should be going up as you move to the right. These are both moving down as you move to the right. So they are hot trash, you throw them in the garbage. So the only possibility is A or C, and I can immediately throw out A because of this point right here. This is not the origin, this is 0, 75. This point is going through the origin, not 0, let's just say about here, so it can't be A. The only one that's even closely resemblant to what it should be is C. It's not a matter of having to look at 2 different points and make sure they're anchored correctly. It's just they gave you 2 answers that were complete garbage, and one that you can figure out is garbage because it goes to the origin, and this is not the origin. It would have to be 0, 0. It almost looks like a face in order to go through the origin. So it looks like it's going to be C. That's clear. Close that. Try out C. And we got it right. Good job. Determine which ordered pair satisfies the equation. This is one I'm going to leave to y'all. You're just plugging, You're just plugging the 4 in for the X and then the 7 for the Y and seeing if you get a true or false statement. If that works, then you click it. And then you'll try the 6, negative 37. You'll plug the 6 in here and the negative 37 in for the Y and see if you get something that makes sense. And then you'll do it for the last point. You'll do it for the 0 and the 37. And it says select all that satisfies. So they're saying maybe it's 1 of them, maybe it's 2 of them, maybe it's 3 of them, maybe it's none of them. I will tell you it's not all of them for, wow, that was extremely loud. I'm gonna Let's do this. The volume on my computer must have reset. The funny thing is I'm only at 22, but that was really loud. All right. Distractions. So again, I'm telling you that for my particular example, it's not all of them, but I'm not going to give you the actual answer. All right. The decline in per capita beer consumption is shown in the scatter plot. What is the slope of the linear trend line? That's going to be part A. And then for part B, interpret the slope in real world terms by filling in the blanks. So that's something we did many times over back in chapter 5 with a guided activity, if you're my student at least. So what we're given here is a series of actual data, and data involving people does not always match a trend perfectly. Very often we need to do that fixed endpoint method, or the anchored method as I like to call it, or the sum of least squares method, which is what Excel would do for us. So Excel is, we plotted these points in Excel, and then we told it to make our line and display the equation, and it thought all that stuff for us. Thank you, Excel, as I always say. What is the slope? Well, remember that for lines, yes, it goes, the thing with the variable is the variable amount, and then the thing without a variable is the fixed amount. But also it's y equals mx plus b, where m is the slope and b is the intercept. So this number right here should be our slope, that negative 0.115. So let's try that out. And you can't forget the negative, negative 0.115. And we got it right. All right. Then our slope in this cookie cutter format, the thing is changing by a number of units per some other unit. So what's changing? It's the per capita beer consumption. That's the thing that's changing. It's the title of the graph, the output, the Y. That's the thing that's changing. And it's changing by, well, that's our number, the slope itself, the negative 0.115. And then these are just the two units, the units of the output per input. So the output is in gallons, and then the input, this seems to be years, so let's say years. And actually, if I do per year, based on their graph, will it be right or not? Let's see. Some people think, oh, this is 1980, then 85, then 90, and then 95, so they'll go 5 years. Spoilers, this is wrong for pretty much the exact same reason as why I got the slope wrong in the last problem. This is actually only dealing with every single year. Yes, the graph is representing every 5 years, but the slope itself is based off of every year. So you have to be careful with something like that. They're trying to confuse you. They're trying to mislead you. And there we go. All right. Consider the graph to the right. In words, describe the function shown on the graph. Then find the slope of the graph and express it as a rate of change, a fraction, or decimal. And then briefly discuss the condition under which a linear function is a realistic model for the given situation. So what we have is, we're looking at time versus distance from home. And this is going down. So if 0 hours have gone by, where it looks like 100 miles from home, and then some of the points in the middle are kind of hard to see, and I could zoom in if I wanted to make this a little better. And we can see that it looks like here, 7 hours in, we are 0 miles from home. So 0 hours in, we're 100 miles from home, and then 7 hours in, we're 0 miles from home. That's what this graph is telling us. So that's a decrease over time. So the distance from home is not increasing, it's decreasing, so it can't be B or C. It's decreasing. This is a downward slope, so it's decreasing. So according to the function, the distance from home decreases by 7 miles every 100 hours. That sounds really slow, because this says after 7 hours, we're home, it looks like, and then at 0 hours, we were 100 miles away. So A has the right numbers, but they seem backwards. They seem backwards to the units. How about D? According to the function, the distance from home decreases by 100 miles every time we go 7 miles. So this distance dropped from 100 to 0, as we went from 0 to 7 hours. So D sounds like the answer. And there we are. Calculate the slope. Well, you can actually do that by the statement above, 100 miles over 7 hours. And they say to round to the nearest tenth. Or you could call these 2 points, this would be x1, y1, which would be 0, 100. This would be x2, y2, which would be 7, 0. And then we just do the slope formula, which you're supposed to memorize, y2 minus y1 over x2 minus x1. And whichever way you do it, you will get the same answer because you'll end up doing 100 divided by 7. So if we take our 100, which was the miles we drove, the change in the height, the 100 is the change in the height, and then 7 is the change in the distance, but because we're going down, it's going to end up being a negative number. So let me actually go negative 100 because we're losing 100 miles from home over the 7-hour period. And you get negative 14 point rounded to the nearest tenth, so negative 14.3. So negative 14.3, and then they say miles per hour or hours per mile. Well, hours per mile is a pretty rare unit, so miles per hour. And that's because the 100 in the top was the miles, the 7 in the bottom was hours, so miles over hours. Then part C, briefly discuss the condition under which this linear function is a realistic model. So this was a case where we were 100 miles from home and we were driving for 7 hours and eventually we got home. Or maybe we were walking, or maybe we were running, or maybe we were biking. Walking would be very tough to go 14.3 miles an hour. Running is still really tough unless you're Usain Bolt or something like that, and I think that's probably even faster than him. So this is probably on a bike or in really bad traffic or something like that in terms of the actual speed number, or maybe we're just making a lot of pit stops. Maybe we're in, what's that place called? In the Shenandoah Valley. Beautiful, beautiful. It's like 25 miles an hour. It's outside of Front Royal where it starts, where you get in. Doesn't matter. We're taking a really slow scenic drive. That's the point I'm trying to get to. All right, so maybe that's the relative scenario, but select the case in which this could be. It's a good model if speed is not constant for 7 hours. Well, don't we need the speed to be pretty constant? So I'm not going to say A. I'm not going to say A. It is a good model if speed is changing for 2 hours and then afterward is constant. I don't know. I feel like we need to be going the same speed, the exact same speed the whole time for this to be consistent. Otherwise, we'd have dots, a little higher and a little lower and a little higher and a little lower, which again would be much more realistic with traffic and stoplights and stuff. It is a good model if the speed is constant for 7 hours. Ooh, I'm liking the sound of that. And then if it is a good model if speed is constant for 2 hours and afterward it is changing. I don't know why they have this whole 2 hours and then constant or 2 hours and then changing, vice versa. B and D are absolutely not it. This is a great model as long as our speed is never changing, as long as our speed is constant. And again, you can approximate things in the real world, but the model wouldn't be exact. Like I said, you'd have a dot maybe a little higher, a little lower, a little higher, a little lower, a little lower, a little lower, a little higher, but then everything would just have a best fit. That's what Excel does for us. That's that linear regression line of best fit. All right. Next up, determine the slope of the line. I just mentioned this equation, and the reason I didn't use the equation in the last one is because I knew this was coming. So that formula, which you are supposed to memorize, y2 minus y1 over x2 minus x1, also known as a rate of change. Excuse me. Rate means fraction, change means subtraction, so it's a fraction of subtractions. And it's always the height over the horizontal. So that's our formula. So if we wanted to label things, this would be x1, y1, x2, and y2. So our slope would be, and you can swap the 2's and the 1's as long as you completely swap them. But I'm not going to. So y2 minus y1, that's -5 minus -1. Watch out for those double negatives because that is a -1. We're subtracting -1 over x2 minus x1, which is 3 minus 3. Minus a negative is a plus, that's -5. Plus 1 over 3 minus 3. You got calculators, but you're still supposed to know your sign to arithmetic. -5 plus 1 is -4. Different signs, subtract, keep the sign of the larger. 3 minus 3 is 0. And this is not something we talked about too much in this class, but we did mention it briefly at the beginning. Anything divided by 0 is undefined. Please note that if these numbers were backwards, 0 divided by -4 would be 0. You need to know which one of these is 0 and which one of these is undefined. So our answer should be B. The slope is undefined, and we got it right. Undefined means if you graphed this, back on the annotate. If we graph this, let's see, we got 3, -1. That's right, 3 and down 1. So there's the first point. And then 3, -5. 2, 3, 4, 5. This is what the line would look like. Please ignore the fact that I'm just a hair off of that marker. That's 1, 2, 3, -1, -2, -3, -4, -5. This is a vertical line. Quite honestly, we do not study vertical lines in quantitative reasoning very often because we don't have any models that are vertical lines. Vertical lines are much more important for concepts in pre-calc and calc, these things like asymptotes. This is an absolutely boring model. There's nothing we do with it. But it's still perfectly valid for calculating a slope. The final, just like the midterm, has some basic just math questions in addition to much more traditional quantitative reasoning questions. All right. Spoilers, this one will have a much more normal answer, but since I already did a slope, I'm going to save it for y'all to do. And remember, my numbers will be different from your numbers. I believe most everybody's 7, it works out to be undefined or 0. And then this one, it works out to be a non-zero or non-undefined number, but I'm not going to promise that. RNG, or random number generators, make things random. All right. So this person is clearly not a state employee at the same job for 7 years, at least not the state of Virginia. As always, shots fired. A person's annual salary increases by $11,375 over a 7-year period. Find the average rate of change of the salary. So a lot of people think average means add up all the things and divide by the number of things. Well, we weren't given a bunch of different things to add up and divide by. We were just giving a total amount and a period over which that happened. So that just means divide the two things. So take the salary change and divide it by the time that it happened over. So maybe we gained $1,000 the first year, the second year nothing, the third year $3,000, the fourth year another $3,000, the fifth year $375. I don't know, but over the 7 years, you are now making $11,375 more. So all we're going to do is take the 11,375, which was the salary, and divide it by the time. That'll give the average change. Average change. The average rate of change, that is to say, rate of change. So this is a difference that we don't have to subtract, it's just given to us, and then from 2020 to 2027 would be a 7-year difference. So just do that calculation. 11375 divided by 7, boom, 1625. 1625, just pretend I read that, please. $1625 per year. And by the way, actually, I'm going to put the annotate back on. That was 7 years. So it's $1625 per year because the year is in the bottom. So that's a per. Oops, take that off. And there we go. All right, intercepts. We said intercepts are where lines intersect an axis, and the name tells you which one you're intercepting. So an x-intercept is where you cross the x-axis. This would be the x-intercept, but they didn't ask us about that. They asked us about the y-intercept. That's where we cross the y-axis, which is right here. So this point would be the y-intercept. So this is the point we want, and there's no number written there, but it looks like it's about halfway between these markers. This is 0, this is 2, so I would say that's a height of 1. Now, they ask us to type an ordered pair, so I'm going to do this wrong at first. Some people will just say 1. And if you were a pre-calc student, there's actually times where that's all we would type. I had to give several students some partial credit for things like that, and I would do the same in this instance for y'all. Your answer must be in the form of an ordered pair. Make sure it's enclosed in parentheses. So it's not just the 1, it's the 0 as well. This point is actually 0, 1. X, Y, left or right 0, up 1. So I can't just do 0, 1 like this either. It's going to be wrong, it's going to be wrong, it's going to be wrong. Make sure it's in parentheses. So we go parentheses 0, 1. You can also use this button to just do it like that. Final check, we got it right. Good. This is one we're going to skip. We've already done a bunch of those little tables. Here we go. Graph the equation. So we're going to make our own graph. I've discussed the several different ways you can do this. I've said that you can use a single point and a slope to rise and run. You can do a couple of different points. I'm going to show you 2 different ways to do this. So the first way is just a table of values. Since this is solved for y, my favorite thing to do is just go 0 and 1 for the x's. So this was my choice. You don't have to use 0 and 1. However, I would stick to numbers between -10 and 10 since that's all we have here. If you plug in 0, you get y equals 3 times 0 minus 5, which is 0 minus 5, which is -5. So that's your first coordinate pair. 0, -5, which will be right here. I'll click that in a few minutes. And if I plug in 1 with x equals 1, that's y equals 3 times 1 minus 5, which is 3 minus 5, -2. So that point would be 1, -2. So we go right 1 and down 2. And there are the 2 points. And then we would just, my math lab does that automatically for us. But I said I want to show you 2 different ways before I get this done. And yeah. Okay, so let's just undo that. Where's the eraser button? Let's erase both these points. All right, back on draw. So or with y equals 3x minus 5, that says the slope is 3, which is 3 over 1, which says wherever you plot a point, you can just go right 1 and up 3 from. And it also says that the b is -5. That's the value of the y-intercept. So we get the point 0, -5, which we already know because we already did it a different way. But if we didn't do it the different way, we would just hope and pray. So this time I'm going to plot the 0, -5, which is the y-intercept. This is my second version of it, which will coincidentally get the same points. It doesn't always get the same points, but this one it will. Then from this point, we'll use the slope to find another point. So I'm going to go right 1 to here, and then I'm going to go up 3, 1, 2, 3, to right here, which is the point 1, -2, which again is coincidentally that one. I get the same exact 2 points, and then I can connect and extend them. And I can find another point by going right 1 and up 3, right 1 up 3, and there would be a point, right 1 up 3, that would be a point, right 1 up 3. I can keep going right 1 and up 3. You've never reset to the origin when you're using the slope. But again, the points were 0, -5 and 1, -2. I need to click those, 0, -5 and 1, -2. So 0, -5. Oh, I thought I hit that first. You got to hit your line. There we go. And then 1, -2. There's the line that I drew with my pen earlier. And we got it done. Nice work. All right. Decide whether the following statement makes sense or is clearly true, or does not make sense and is clearly false. Explain your reasoning. I graphed two linear functions, and the one with the greater rate of change has the greater slope. This makes sense. According to the definition of linear functions, the initial value is equal to the slope of the graph. Thus, the rate of change does not relate to the slope. Well, this says, makes sense, so true, but this says the one with the greater rate of change had the greater slope. These seem to be contradictory ideas, that the rate of change does not relate to the slope, but this says the one with the greater rate of change has the greater slope. This says they relate, this says they don't, but it says true. So it's definitely not A. This does not make sense. According to the definition, the slope of all linear functions must be the same. No. The slope of all linear functions can be whatever the heck they want to be, whatever the heck they need to be. Also in A, something else that was wrong is the initial value is not the slope of a graph. Slope and initial value are completely independent of each other. So B is trash because slopes of lines can be whatever given the scenario. C, this makes sense. According to the definition, the rate of change is equal to the slope of the graph. Whispering into the mic, something I said earlier. So the greater the rate of change, the greater the slope. C's sounding pretty good, but let's check D just to make sense. This doesn't, I'm sorry, to make sure. This does not make sense. According to the definition, the initial value is equal to the slope. I've already said that the initial value and slope are not the same thing, so that's trash. Thus, the rate of change does not relate to slope. It's literally the exact same statement as A, here and here. It's just one says makes sense and one does not make sense. This is very common in these answers. And sometimes it's one of those two things that would be right, but in this case, neither of those is right because they're spitting out hot trash. Initial value is the slope. No, it's not. C is definitely the answer. We already did one of these, and I discussed it in both ways, so let's move on. Here we go. Use the compound interest formula to determine the accumulated balance after the stated period. $6,000 invested at an APR of 9% for 10 years. It's compounding annually, and they want to know how much we have after 10 years. They already said that. Well, that sounds like one for a formula sheet, which I do not have open, but I can open really quickly. Boom. All right, 8 formulas. Well, this clearly isn't a loan. It's clearly not just converting APR to APY. So the question is, let's narrow it down to these 3 things or these 3 things. The top 3 and the bottom 3 basically go compound annually, compound in times, and then present value needed. Compound annually, compound in times, present value needed / payments needed. So what's the main difference? Well, first of all, these 3 are much more complicated formulas. These are simpler, so you probably just want to think, oh, let me use a simpler one. Well, that's not always true. It's about whether it's a one-time deposit, which are these 3, 3, versus a multiple deposits. Yes, I spelled that wrong. Just go with it. We are not making multiple deposits. So these 3 are out. We are making a one-time deposit. How do I know that? I read the question carefully. We're putting $6,000. It doesn't say $6,000 annually. It doesn't say $6,000 monthly. It doesn't say $6,000 quarterly or daily. It says $6,000. That's a one-time deposit. So we're under one of the top 3 formulas. We're narrowing down. Are we compounding annually or are we compounding in times? Well, we're compounding. It says, where is it? Annually. So that means we definitely don't need to use the second one, but it could still be the third one. You might say, oh, well, compounding annually, so don't use that one. Well, it's a matter of what do we know? The first one is when we know the start, because that's the P, and the third one is for when we know the end, which is the A. We don't know the ending amount, we know the starting amount. So that means this is our formula. The one that I suggested for my students to memorize, even though it's on the formula sheet, because this is just previous balance times growth factor raised to time, which is an extension of previous balance times growth factor. Just that's for 1 year. This one right here is for multiple years. All right, so we're going with A equals P, parentheses 1 plus R. Oops. I don't know why I started opening another parentheses to the T. This is our P, this is our R, and this is our T, but make sure that the R is converted to a decimal. So that's $6,000 times 1 plus 0.09 raised to the 10. And that's all we should have to put in our calculator. Alternatively, what you could do is build an Excel spreadsheet really quickly and look at what happens years 1 through 10 with a simple growth factor every year. But it's not exactly what I'm looking for with a test. You're not supposed to be opening Excel for a test. So 6,000 times, and you may have to hit times, I don't have to. And then 1 plus 0.09, close it, raise it to the 10th power. And we get 14,000 and some change dollars. 14,204, we're rounding the nearest cent. So 14,204.18. We got it right. If you can read through that, excellent, check mark, yes. Annotate, clear. All right. This one is very similar, but there is one drastic difference which will cause us to use a different formula. $16,000 is invested. So this is a one-time deposit, so we're under those top 3 formulas. For 4 years with an R of 4%, and we're compounding daily. This right here means that we have an in, so we don't use the first formula. We're going to use the second formula. Why is this being silly today? I don't want to erase that stuff, actually. I want to erase this. So again, we are compounding daily, so that's out. We know the starting value, so that's out. This is also a no start, by the way. So we're on this formula. We're not using any of these formulas down here because these would be multiple deposits and we're only making a one-time deposit. So A equals P parentheses 1 plus R over N raised to the NT. So that will be our formula. Let's go to annotate. A equals P parentheses 1 plus R over N raised to the NT. So with this being your P, your T, your R, and the N daily being 365, means we're gaining money every single day for 4 years. It tells us A equals 16 grand, parentheses, 1 plus 0.04 over 12 raised to the NT. That's 12 times how many years? 4 years. Now, I did say to make sure you pre-multiply your exponents for your calculator. 12 times 4 being 48. That's what we're going to put in our calculator. So 16,000 times 1 plus 0.04 divided by 12, close the parentheses, raise it to the 48th power. Now, if I got some answer like $10 billion or $5, these would be drastically wrong. You want to make sure your answers make sense. 18,000 and some change, that sounds good. This interest rate isn't super high, the time isn't super high, so I don't expect this to turn into $1 million. I'm not continuing to add to the pile. That would have helped as well. So 18,771 point, that's 0.178, so 18 cents. 18,771, 18. What am I doing wrong? Oh, I know what I did wrong. Why did I do 12? I got sidetracked. This and this are wrong. Those were wrong. We're compounding daily. That's where the N is supposed to be. That was supposed to be 365. So I am so sorry for that. That's wrong. It's supposed to be 16 grand, 1 plus 0.04 over 365, raised to the 365 times 4, which 365 times 4, I just had months stuck in my head for some reason, and I would have gotten that wrong. You know, it will be close. Our answer is not going to be that far off from $18,700. $16,001 plus 0.04 over 365 raised to the 1460. Let's try that out. We'll get the right answer this time, I promise. 16 grand times 1 plus 0.04 divided by 365. Close it, raise it to the 1460. I should have caught that didn't make sense because if we're compounding daily, we're going to gain interest more than 48 times. We're going to gain interest almost 1,500 times. And look how close that answer is. It's only $5 off. So, I mean, in terms of you being close, you probably won't care in your whole life. But for the math class, you have to be exact. That 0.009 will round up to 1 cent. So let's get it right this time. 18,776.01. Let me clear my screen just so you don't see all that nonsense there. And now we got it right, thankfully. All right, we got time for about 2 or 3 more. Decide whether the following statement makes sense or doesn't make sense, and explain the reasoning. A small town that grows exponentially can become a large city in just a few decades. The statement makes sense because exponential growth leads to repeated doublings, making the population increase slowly. Okay, well, exponential growth does lead to repeated doublings, but that can make the population increase quickly. So it's not A. Can't be A. Doesn't make sense. Can't be that. B. The statement makes sense because exponential growth leads to repeated doublings, making the population increase rapidly. So it's just the contradiction of the first one. Instead of making it increase slowly, increase rapidly. Well, repeated doublings can make the population grow rapidly. Okay, so B might be it. Let's go through the others though. The statement does not make sense because exponential growth cannot continue indefinitely, so the population will not get large enough for the town to be considered a city. So C has some stuff that makes sense that I've tried to hammer out to y'all over and over and over, that exponential growth, especially with population dynamics, doesn't continue forever. It eventually flattens out for basically population cap reasons, that eventually we're going to run out of room. But if you're a small town, are you going to run out of room that quick? I don't know. So C has got some sense to it, but I don't know if that's what they're looking for, right? That's what you're thinking. So it can't grow indefinitely, so the population will not get large enough for the town to be considered a city. I don't know. It's got a part that makes sense, but I think a town could certainly turn into a city over time. I don't know about C. Between B and C right now, I think. The statement does not make sense because exponential growth leads to repeated halvings. Complete trash. Exponential growth leads to repeated doublings. Exponential decay causes halves. You'll half it, half it, half it, which we did skip that guided activity, but I did at least talk about the basic idea. So it's definitely not D. It's definitely not A. We're between B and C. I don't like that part of C necessarily. I know what the answer is, so am I leading you right or wrong? The basic idea here is B, and it is. So my problem with C is it does give you some things that I've emphasized, but the last part doesn't have to be that way. A town can certainly turn into a city. New York City was at some point a town. They have more than 10 million people now, so a town turned into a city. So I really like that answer C in terms of trying to throw you off. And I know that sounds evil because it has a fact that's correct with it, but then also something that's not correct. So you have to check all aspects of these answers. Skipping that one. What is correlation? Give 3 examples of pairs of variables that are correlated. A correlation is only when 2 variables tend to increase or decrease together. A correlation exists between 2 variables when higher values of one consistently go with higher or lower values with another. Correlation is only when 2 variables tend to change in opposite directions, or a correlation is when one variable causes another variable. So that chapter 8 stuff, I hammered out correlation versus causation. Causation means one causes another. Correlation is they happen to move in the same way or in opposite ways consistently, but it's not necessarily because one causes the other, like the whole pirates don't actually cause global warming, but the number of pirates went down while global warming went up. So it's definitely not D. It's not D. The others, a correlation is only when variables tend to increase or decrease together. Maybe that's it. A correlation exists between 2 variables when higher values of one consistently go with higher or lower values of another. Correlation is when 2 variables tend to change in opposite directions. C is not the answer. I can tell you that much because they can both go up or one can go up and the other can go down. So the pirate example, pirates went down, pirate population, and global temperatures went up. So that's an opposite correlation. But it can also be correlation with as you sell more apples, you make more money. So they both go up. So correlation they can both go up, they can both go down, or they can go in opposite directions. So C is only half right. So let's see. Is it A or B? B. 2 variables with higher values of one consistently go with higher or lower values of another. That sounds like it could go either way. Correlation is only when 2 variables tend to increase or decrease together. So A actually sounds like C in that if one goes up, the other goes up, or if one goes down, the other goes down. It's not allowing one to go up and then the other to go down. So let's try B. And we got it right. Give 3 examples of pairs of variables that are correlated. Production cost of movies and gross receipts of movies. So does the cost reflect the money coming in for it? Per capita personal income and the percent of the population below poverty level, and then height and weight of people. Height and weight sounds good. Percent of population below poverty level versus per capita personal income. Well, that would be an inverse correlation maybe. So A is a maybe, but I don't know about that first one. Just because you have a high costing movie, does that mean you're going to get more money off of it? There's plenty of movies that might argue with that. All right, amount of smoking. I just combined smoking and lung somehow with smoking. Oh boy, that's a weird sounding word. Amount of smoking and lung cancer. So the more you smoke, the more lung cancer you get maybe. Height and weight of people. So we liked that one before. The taller you are, the more you might weigh. The price of a good and the demand for a good. So if you bump up the price, does demand go up? Well, no, I think if you bump up the price, demand would go down. I'm kind of liking the sound of B so far. All right. C, the Super Bowl winner and the performance of the stock market. So that kind of sounds like pirates and the weather, right? Amount of smoking and lung cancer. Well, we liked that one for correlation. Per capita personal income and the percent of population below poverty level. So I kind of like the last two, but Super Bowl winner and the stock market. I don't know if the stock's going up because the Super Bowl winner was picked accurately, or because one team won versus the other, or the stock market goes down because Dallas won. It just sounds weird, right? It doesn't really make sense. Could they correlate? Maybe, but I'm not liking it. Production cost of movies and gross receipts of movies. We already said we don't really like that one. Inflation and unemployment. I've given you inflation charts before. Go to the internet and pull up an unemployment chart, and you might not see too much correlation there. Super Bowl and stock. Wow, this one just sounds like complete trash. D sounds like the worst of them all. The only one that seemed to have 3 good ones was smoking versus lung cancer, height versus weight, price of good versus demand. I'm liking that one. That would be my choice. And we got it. Last one, and we'll call it a day. We'll call it a semester. And remember, for this MDE4, this is it. You don't have any tests. You don't have any homework. You're just here. Hopefully you've been doing the homework assignments. I'm speaking to myself here, but I've got to find a way to influence students to do more of the homework. 2 or 3 of you did a good job for a while. And at the same time, we also suggested that if you were kicking butt in the Math 154 course, it's not the end of the world if you stop with the MDE 54 stuff. So my students making B's and C's in 154, I'm not mad about you not doing work in MDE. But the students who didn't make A's, B's, or C's in 154 and you're still hanging out MTE and you haven't been doing your work, maybe you should have been doing more work. And again, this is just, I've got to find a way in the future. I've got to find someone to change the system, basically. I want to be able to force y'all to do homework, and I can't right now. And that sounds really, really contrary to a normal class, but this isn't a normal class, as you know. All right. Define and distinguish among positive, negative, and no correlation. How do we determine strength of correlation? So first of all, positive correlation means if one goes up, the other goes up. So positive correlations means that both variables tend to increase or decrease together. Sounds good to me. That's weird. Usually it just continues automatically. Define negative correlation. This is when they go opposite directions. So negative correlations mean that both variables tend to increase or decrease together. No, we said that was positive, so it's not A. Negative means there's no apparent relationship. That's no. That just means there's no correlation. Negative correlation means there's a bad relationship. That would just be weak correlation. Negative correlation means the 2 variables tend to change in opposite directions, with one increasing and the other decreasing. Boom, there's our answer. Define no correlation. Means the 2 variables are always 0? Absolutely not. No apparent relationship between the variables. Ooh, that sounds good. They tend to change in opposite directions. Well, we already said that's negative. Tend to increase or decrease together. We already said that's positive. No correlation means no relationship. Weak correlation would be weak relationship. And there we are. So
All right, so that's all we're going to have time for. I hope that last hour has been helpful. Like I said, I thought a review for the final, since we had time, would be good. I could have done another topic from chapter 9, but it might have just been a little convoluted, so I went with that instead. And then our reminders here for due dates and such, in case you missed it at the beginning. But again, everything will be available in the YouTube replays later. But the biggest and most important thing out of all of this is our final exam on the 29th, this Thursday, covering chapters 1 through 8. Do not miss it. There will be absolutely no late exceptions of the final. If you cannot take it on the 29th, you need to let me know today, and we can let you take it on the 28th or something like that. But we're really not going to be able to let you do any late finals because I have to have grades into SIS and everything, and then you'll be able to find your final grades on SIS possibly Saturday morning. I can never remember if they update the system on the weekend. It might be Monday until you have to wait in, but I'll be submitting those grades late on Friday evening. Email me if you have any questions per usual. Make sure you get those last 2 quizzes done. Make sure you've knocked out those last 2 My Math Lab homeworks. You have the optional Excel homework if you want to swap out a bad grade from before. That gives you a possibility to make that up. Remember your reviews, the 2 different ones, the one in Canvas for the first half, the one in My Math Lab for the second half. Remember that the final will only be visible on the day of the final, and the same will be true of the work submission for the final. You've got your formula sheets and Canvas to download and use. Hopefully there's no confusion, even with all of these great grand details like it's always been in QR. But I know this has been an interesting format, like I've said, to have to learn through this. I'm very, very proud of y'all for making it this far, and I hope we can continue to the finish line on Thursday and all do well. I wish you the best of luck in anything in your futures, especially math. I hope that you are able to use some of this financial information for positive gains in your life at some point sooner than later, hopefully. And I wish you the best of luck in any future math classes and again in all your other math classes. But take care, everybody. Remember, no class on Thursday. This is it. Please don't forget to leave reviews. You should have received emails about that. I think you do that through SIS. They've changed it recently. But yeah, all right. Take care, everybody.